Exercise 1109 is properties of inverse trig functions. So we've got a sine curve here and we've been asked to evaluate sine inverse of root 3 on 2. So I do have my exact value triangle here, and I've also got my sine inverse curve drawn here. Now you might compare it with this situation where sine x equals negative root 3 on 2, and we saw there were infinitely many answers, but the problem is this is not our sine inverse curve. This is absolutely not. It is a function, not a relation. This is a relation. We did have to limit it, so this is all gone, this is all gone. There aren't infinitely many answers down here. There is literally only the one. So you can compare it with this situation. So if you've got y equals the square root of 9, then the answer is literally just positive 3. Whereas you've got y squared equals 9, then you've got plus or minus, y equals plus or minus 3. This one has two answers, this one only has one answer. This has infinitely many answers, this only has one answer. And that's over here, right there, where we've got negative square root 3 on 2. Now to find that, you can use your exact value triangle. Now I'm also going to compare with the unit circle. So one thing about this sine inverse curve, we know that its domain is from -1 to 1 and its range is from negative pi on 2 to pi on 2. Now that means our solution must be between negative pi on 2 and pi on 2. So our solution is in quadrants 1 and 4 only. Now because it's negative, we've got our all stations to central to consider. We're only looking in these two quadrants between negative pi on 2 and pi on 2. And it's negative, so it's down here. It's down in this quadrant here. But the negative, we're going this way. Okay, so we're not looking at 360 minus, we're looking at negative that answer. So if we look at our exact value triangle, if it was just root 3 on 2, we'd be looking at this angle. Sine inverse of root 3 on 2 is pi on 3, but because it's negative, so if it was positive, it'd be pi on 3 up there, but because it's negative pi on 3 down there. It is an odd function, which we will actually be proving. So the answer is negative pi on 3. Also negative 60 degrees, but we generally work in radians now. Okay, we've also got the question about evaluating cos inverse -1. Now, as I've mentioned before, when we've got zeros, ones, minus ones, we're much better off looking at curves than we are looking at the unit circle. They're much more effective. So with the cos inverse function, our domain is -1 to 1, our range is 0 to pi, so our answer needs to be between 0 and pi. Now, when we're at -1, that's over here, so here's our solution right here at pi. The answer there is pi. Okay, that's one. If you put that in your calculator, for example, it's going to be in terms of pi. So you can see that, you can recognize that as pi. But remember, if you divide out the pi, it'll give you the coefficient of pi. So it's 1 pi, right? 1 pi is our answer. So pi is our solution there. We don't have infinitely many solutions anymore if we're asking about cos inverse. Remember, if we were saying cos x equals -1, infinitely many solutions. But here, just the one solution. So it depends on the phrasing of the question. So this next one is tan inverse 1 on root 3. So here's our tan inverse function down here. Again, it's got the same range as our sine inverse function, so it's quadrants 1 and 4 again. Remember, cos inverse was quadrants 1 and 2, it was 0 to pi. This is quadrants 1 and 4. So sine and tan, the odd functions, are both quadrants 1 and 4. Cos is an even function, that's 0 to pi, and that's really important to remember. So tan inverse of 1 on root 3 is going to be up here somewhere. I haven't put any numbers on there. There's our 1 on root 3. It's going to be a positive answer. But we're best to look at our exact value triangle. So 1 on root 3, this is our opposite, this is our adjacent. Our answer is pi on 6. Just the one answer, not infinitely many answers. Okay, this last one on this page, cos of sine inverse root 2 on 2. Now remember, root 2 on 2, that's the same as 1 on root 2. Okay, it's the same thing. It's just this has been rationalised. So we just need to go in steps here. So sine inverse of 1 on root 2 from our exact value triangle is pi on 4. So that's the same as asking what's cos of pi on 4. Now that's kind of a fun one because we actually get back to our 1 on root 2. Cos of pi on 4 is 1 on root 2 because the opposite over the hypotenuse is the same as the adjacent over the hypotenuse for this particular triangle. So that's a bit of a fun one.